Okay. Okay, so this is going to be a little bit of a change of pace, a little bit more technical, but not super technical. And no, you did not get transported to the year 2023. It really is a RAG-based session. This will lead into a second session by me about MCPs. And this will also lead to me demonstrating what Surya had mentioned, our new summarization feature. So someone actually mentioned RAG in a question earlier. Has anyone not heard of RAG before? Or maybe kind of heard the term but don't know what it actually means? Okay, good. So I'm going to go over just, this originally was going to have a lab, and you were going to write Python, and then I kind of changed my mind. That was ambitious. So, Greg, what was the peak of the hype cycle called again?
Inflated expectations.
Yes, inflated expectations. I have a condominium at the peak of inflated expectations. I'm the penthouse. And my secret is I just move on to the next shiny thing, and I never fall into the trough of disillusionment. So if you just stay up there the whole time, the air is thin, but it's good. So we're going to move into 2022, ChatGPT 3.5 comes out, human inflection point, societal upheaval changing event. Most people using it through the GUI. Some of us actually tying into the REST API. I would argue that AI had a 1.5 phase, basically this gap here, using retrieval augmented generation to overcome the shortcomings of one, very small context windows, and two, just the lack of context in general. And obviously we have AI agents as 2.0, and we'll see how MCP gets there. So I don't need to belabor the point about GUIs, but the key here is there's no contextual understanding. And it was really manual, why is the sky blue? Could you tell me more about light refraction? And you just chat with the thing. And it seemed like a fun toy. Some of us were looking further and tied it into REST APIs. So I use a particular network automation framework called PyETS, but it could be Ansible or anything else. And as soon as I got REST API access, this would have been December of 2022, so a month after GPT, can I do show IP route with PyETS and get the routing table back as JSON and send that as context to the LLM and ask, what's my default route? And when that worked, I was like, this is not a toy. This is going to overhaul my entire industry and maybe the world at large. Remember my condominium at the peak, right? So RAG really was a way to combine LLMs, large language models, with external data sources, right? So if I just say, what is my default route, ChatGPT might make up a number. It might say, I don't know. It might say, here's how to find the default route, right? The other thing about hallucinations, this really helped dramatically reduce, not eliminate, hallucinations. Scientists now believe that hallucinations are mathematically impossible to eliminate. It's not something that will go away. I've been reading some papers about this in the sciences. It's just, you're just going to get hallucinations. So it really adds that context awareness. But it's not autonomous. We're not quite at autonomy yet. And then we get into agents that have, for lack of a better term, agency. They have agency to run commands without human instruction. They can reason, and they can run tools. But how do we get to agents, and is RAG obsolete? I would argue it's not. Some people would say we have a 2 million token context window now. So why do I need RAG if I could put half a library worth of PDFs into the context window? I have yet to see science prove that. What if there's disparate or conflicting information within that one big context window? There's also the idea of the attention to the middle of the context window. So the first part and the last part of the context window is it works very well, but the larger the context window, that middle chunk sort of gets lost in the inference. So RAG is actually a 6-step process, and we're going to break it down to make it very simple for anyone to use. First of all, we need to find our source. And that could be almost anything. And I'll show you a list of sources: PDF, PowerPoint, Word, JSON, HTML, SQL, you name it. Now, typically you need a loader that matches your source. So here I'm going to load a GitHub loader if I want to chat to GitHub, a YouTube loader if I want to talk to YouTube. We need to take, let's use a PDF as an example. Let's say it's 100 pages of PDF. To transform it, we're going to break it into logical semantic chunks. Now, this started as a manual process. Let's split on every 500 characters. Let's split on every paragraph. Let's split on every sentence, an exclamation mark or a period or a question mark. Flawed approach. What if when I chunk my data, I mix the OSPF information with the BGP information? Or I have all of interface 1 and half of interface 2, the rest of interface 2 and part of interface 3. It just wasn't good. It was better than nothing. Well, now, what do we use? We use a model here. So it's turtles all the way down. We can use AI to semantically chunk things with much greater accuracy. The next thing is, now that we have chunks of text, so let's say it went from 100 pages of PDF to 1,000 chunks, logically grouped, we need to turn that into something that the machine can use, which is floating point numbers, 16-bit floating point numbers. And these are arrays of numbers. And what do we use to do this? A model, not a large language model, an embeddings model. So these are known as the embeddings, or the vectors. Once we have all that data, we need to store it somewhere, a vector store. Now, this is not a SQL database. It's not a relational database. It's not a flat structure. It's a specific type of database that stores these floating point numbers in the vectors. I haven't said anything about ChatGPT or LLMs yet at all, right? I'm using an embeddings model here. Finally, when I get to the retrieval, that's where my large language model, the prompt comes in, what's my default route? And I do a semantic lookup. So let me back up a step. That question that comes in, when we ask questions of ChatGPT or Claude or whatever, it doesn't look at the words. That gets turned into floating point numbers that the LLM can understand. And it does basically this process, but against its pre-trained data set. Do I have any close similarity searches to the floating point numbers the user has sent in as a prompt? Well, in this case, we do a semantic search. They ask for the default route. I'm going to look up the closest vectors and return that default route information, augmenting the generation. In this case, essentially eliminating hallucinations. So your source could be a lot of things. Productivity tools, social platforms, web pages, cloud providers, a whole directory of files. So RAG could be your entire PDF knowledge base, using a folder loader as an outer loader and a PDF loader as the inner loader. So load this folder, and the files you're loading are all PDF. Put them all in the vector store, and now I can start doing semantic search. Now, if that LLM that you're using is private or an enterprise agreement, walled garden, totally safe, right? We're talking about maybe even patient records. Or someone mentioned, William mentioned POVs or contracts, whatever you want to put in there. Going the wrong way. Now, in terms of the code, and this is the big advantage of MCP. I'm doing this on purpose because there is code involved in this 6-step process. You've got to write the code for each of those six steps. So in this case, I'm going to use a JSON loader that I'm importing from document loaders from LangChain. I set my path. I set up my loader. I do docs equals loader doc, and now I can do things like print page 100 or show me the metadata of this PDF, right? Now, for the full list of document loaders, I've included the link here. I've sort of already covered this, but we started with splitting based on tokens or exclamation marks or periods, but we get mixing of unrelated topics. Or you might get, say, show IP interface brief, but you've only captured the first 500 characters in that chunk, whereas I want the whole table in the vector store. Well, we can use a semantic splitter, which is just a cloud model, an embeddings model, that uses concept changes, right? So that show IP interface brief, it knows all this data in this table belongs together, embed it as one big table, right? Static routing, EIGRP, right? It will take a running config and semantically chunk it and organize it correctly. And it ensures that it's coherent, self-contained, and relevant to that single prompt that comes in. So this truly is what how do I configure BGP authentication looks like to the LLM. A fixed length vector of floating point numbers, which means we can do similarity searches semantically against it. So this is sort of a visual, right? We're going to embed that text as a vector. So we use the embeddings, the document to embedding. We have the floating point numbers. And now we kind of have this distance in three-dimensional space where the user's question comes in and we're trying to do the semantic matching. One way I've tried to describe this is if we could have a 3D globe and say, show me on the globe, in relation to where I'm standing here in New York, everyone I went to college with. Some people might be in New York, and the distance would be like that. Some people might be in Asia or Europe, and we have this distance, almost vector relationship between the floating point numbers. Did that confuse you more than help you? No? Okay. And then we store it. So the vector store, and there is a growing, well, if we went back a year, I would say there's a growing, highly competitive market in the vector store space. Hyperscalers want to have their own, and they want you to store your vectors in the cloud with them. ChromaDB has become the de facto open source free way of doing this. Now be careful, because there is some telemetry that Chroma sends to its cloud. So just be careful that there is some metadata that leaves Chroma. Now, if you unplug your network, it still works, but there is some metadata trickling out to the cloud, so be careful with that. Pinecone is a purely cloud one. Does anyone use Elastic for anything at all, an Elk stack? You could convert your Elk stack in with an adapter and start storing your vectors in Elastic. Now, what gives you the advantage of Elastic, I use Chroma, but my favorite one is Elastic because it comes with the Elk stack. So I get Cabana to visualize all this stuff. I could turn on the Elastic machine learning on the vectors, so now I have machine learning working against my embedded vectors. Really nice ecosystem with Elastic. So this is just what that last step looks like, right? So the queries come in, and the query's been embedded, and we're just simply doing the closest match on these floating point vectors in a most similar way. Okay, now this is where it gets fun. People ask stupid questions. Present company excluded. Now that's meant to be funny, but we can actually do something about this. So when the question comes in, why don't we reword it with AI? We have a generative AI language model. So what I like to do is something like this. My stupid question, please provide a SWOT analysis of the Cisco annual report with highlights and insights. And I've uploaded the annual report as a PDF, and it's gone through those 6 steps. I can say, please generate, and in this case 4, similarly worded, of similar tone or sentiment or word selection or sophistication or technical accuracy. Or give me the opposite. If they've asked a really technical question, give me a dumbed down version. We as the programmers of RAG, so you can see, I'm not going to read all these, but one talks about competitive positioning in technology industry and identify their strengths and weaknesses. One talks about revenue streams, expenses, profitability. Another one's about societal environmental implications. Give it a more full spectrum of the user's original question. And they don't need to see this. This is purely for us processing behind the scenes. Now this gets interesting because we can do it on the other end of this process. So question comes in, we generate X number of similar questions, we get all the answers, and we present the answers to be summarized to a single answer. There's opportunity here. Okay, so RAG Fusion is the idea of going a step further and reciprocally ranking these answers, or re-ranking the search results. Now, I like to go a step further with synthetic answers. So we can use other methods to evaluate and rank the best answer, or we can round robin against multi-AIs to get different perspectives and then synthesize those into so-called best answer. We could even bounce each AI's answer off of each other, right? So that each AI can evaluate all of the answers. And we get this nice funnel approach if we want to re-rank the answers. So re-rank these based on, this is Claude, this is Gemini, this is Llama 3. I can give each of the answers weight, and then I can do some synthetics to give the best answer. Okay, now, RAG has some drawbacks, and I'm not going to read all this, but let's take, right, so they're short, contiguous chunks of text. If I uploaded the whole book of Cinderella and asked how many evil stepsisters does Cinderella have, very good, it would be able to answer that. How did Cinderella get to her happy ending? Well, that's a more philosophical question, right? Like, that needs more than just semantic matching. So what we can do is build raptor trees. Now, what they call raptor is recursive, abstractive processing, and the key here is tree-organized retrieval. So we're still dealing with vectors, and we're still dealing with chunks. Has anyone ever built a data center, spine leaf? Does anyone go, that's a spine leaf Clo architect, I can deal with this. That's a data center. There's my root, there's my spine, there's my leaf.
Three-tier cloud.
Right? So I'm going to chunk all those texts. And what happens is first we cluster them, and Surya did a whole thing about clustering. So 1, 4, 5 might be everything about the evil stepsisters, 2 and 3 about the pumpkin carriage, 3 and 5 about the slipper. Then we summarize the clusters, and we do this recursively, hence recursive, until we run out of tokens, or until we've reached root. Now, what does this look like left to right? It's a little easier maybe to understand. Raw documents, clusters, cluster summary, and then cluster the summaries of clusters. And we do this until we get to the root. Now, closer to root, the more high level we get. How did she get to her happy ending would be something answered up here. How many evil stepsisters does she have would be from a raw document or somewhere in the summary layers, right? So here's what it looks like. I did that annual report from Cisco. It made 500 leaf nodes that it clustered into 22 clusters. Here's the table of floating point numbers. And as of here, we have 22 clusters. Well, it was able to summarize those 22 clusters into 4 spines. So this is a 3-level tree with a root. And the prompt can follow any of those paths through the tree to get either high-level answers or low-level answers. Okay, graph rag. This is a graph rag. It's hard to see on the screen, but you're going to see big, heavy bolts of color, stronger connections, communities, and some outliers. This truly is the knowledge graph of the PDF. This image cost me $72 to make. And I'll explain in a second. So this is a little different than the raptor tree. It's kind of a similar idea, but we're going to make knowledge graphs. So something like Neo4j, where we have connections more than just vectors in a database, right? And it's bottom-up clustering into semantic clusters. This borrows heavily from the raptor tree. This came out after raptor. Microsoft has an amazing landing page for this if you're interested in GraphRag. They've written a huge, like a real nice portal about knowledge graphs. And somewhere in there was a little asterisk saying, be cautious, this can be expensive. And I just went, meh, and I hit enter. And before my job had finished, I got an email that I'm out of money on my ChatGPT account. I look up on my screen and it's failed because I'm out of tokens. And then my wife's calling going, we just got like a $100 bill on the MasterCard. Like, are you doing something with ChatGPT? Yeah. So Warning. I abandoned my first graph RAG when it hit about $65, then it took another $20 from me because I cancel, right? However, if you use local models with a tool like OLLAMA, has anyone heard of OLLAMA or LM Studio? Okay, not Llama the model, OLLAMA the framework to run models. Free, private, local. Now you need to have a serious GPU or a lot of time on your hands as it builds this graph. And be careful with cloud models because of the cost. I'm just going to mention TAG is table augmented generation. And there's been many, many attempts at text to SQL with Python libraries. There's been many attempts at trying to just do text to SQL. That's what TAG is for. And it's a similar idea where the prompt's going to come in, but the prompt gets turned into a structured query. And we execute the query, and the answer that comes back from the query gets added as context. Very cheap, very fast, very easy. You could do a tag against a routing table in, 45 minutes or something. Okay, so fine-tuning, not training a model. I don't think anyone's going to be in the training model business other than hyperscalers. Maybe Ford or Coca-Cola might train their own model from scratch with a GPU farm. Maybe Lumen, I don't know. Probably not. We're going to fine-tune foundational models. You can use RAG to build the data set that you then use to train the model. So we're going to use AI to generate the data set to train AI with new information. It's a bit circular, but it actually works quite well. So the fine-tuning is a process of taking a pre-trained model and tuning it on a smaller targeted domain-specific data set. Maintain the original capabilities, but add in your domain-specific knowledge. So we load a data set, we prep that data, we fine-tune the model, and then we start doing inference. And here's the visual. They reference this as kind of an open book, right? Now, I've done this, one in ChatGPT in the cloud, so you can fine-tune ChatGPT in their portal and then do inference. So it was kind of fun. I used PyTS to get the routing table, and then I used ChatGPT to generate 100 questions with correct answers. What is the default route? Here's the default route. What IP is on this interface? Or whatever the questions were. And I used RAG to answer that questions. So now I have 100 questions with correct answers. That's my data set that then I use to fine-tune the foundational model. So then without RAG, without anything at all, I can say to the model, what's my default route? And it knows my default route because I forced that knowledge into it. Now these are two opposite ends. I can use RAG to achieve that and point to the data externally, or I can fine-tune the model and bake the answers into it. I don't have a preference. I'm not saying one's better than the other. Those are the two options. Now, agents can use RAG. Ignore this for just a second. Forget that this is even on the screen. What you're looking at here is a LangGraph React agent. Now, we've heard a lot about agents today. I would prepend it with React. Now, React doesn't mean like I'm going to react to what John just said. It means reasoning, so our new reasoning-capable models, and not all models are capable of reasoning, and actions, meaning tool calling. So those are the 1-2 punch that led to MCPs. Models can reason, and models can call tools. So we better have a protocol to wrap all that up in, and we'll get to MCP later today. But what happens is the prompt comes in. What is my default route? And the assistant says, well, I have tools that I can use, MCPs, and one of those is show IP route. So I'm going to run that tool. I'm going to handle the response, and then exit out and give the user their answer. What I found, and Jeremy was along this journey with me, I started to plug in every MCP I could find into tools. So now I have 120 tools. And the prompt comes in and says, hey, what's my default route? And this says, let's grab the message of the day tool. I don't know. Why not, right? So it's hallucinating in its tool selection. And whoa, that's interesting. And Dwan and I talked about this as well after I figured an approach. So what I thought was, well, I have the tool descriptions and their names. Why don't I put those into a vector store and do RAG here? So the question comes in, what's my default route? The LLM says, oh, I'm going to take that and do a semantic search against the tools that I have to help pick and influence the best tool selection. I like Greg's approach of a supervisor and having a hierarchy and not having 100 tools here, having the tools that apply to this agent. But this was early, right? This was trailblazing stuff, and I needed to figure out how to get the right tool. And in my penthouse apartment, I'm like, RAG is the way to go, and it all worked. So here's some resources if you want to try this stuff. This will all be distributed to you. I have buddies, which are basic RAG, packet buddies to talk to packets, document buddies to talk to documents, document and packet raptor trees, the highly expensive knowledge graph, and a tag example. Let me just quickly check the time. Yeah, 7 minutes, good, perfect. Okay, so let me pause, hang on. So this is going to be a view into the new Selector summarization button. Now, a couple things before I play the video, because it's kind of rapid fire and different use cases. We have a dashboard, which is made up of widgets. We can summarize at the dashboard level with a button, or we can summarize at each widget level with the button within the widget. If you're within a widget, it's actually simulating you clicking through the widget. So I might show a BGP hexagon that's red. And if I clicked on that, it would be made up of 4 or 5 other widgets showing why it's red. The summarization button simulates a human clicking the red and evaluating all the sub-widgets. This is a really powerful, and this is the first look that you're going to see. This is the first time it's been presented. So AI-generated summary. We click on the little summarize button, and this is summarizing everything on that dashboard in a nice, quick, simple human to read. I'm the knock, I wake up in the morning, are we healthy? I don't know, just click the summary button. Here is syslogs. Whole breakdown of syslogs based on the syslog severities here. Wi-Fi is a good one. Look at all the access points. Imagine Wi-Fi in an enterprise. This is every state across the country for a retail outlet. Do you want to make sense of this? All that stuff, whoops. Sorry, that is the last slide, and yeah, I went too far. I've gone too far. So you got to watch a couple of them again. The point with the Wi-Fi is, though, is like a retail outlet, or even something. Look at all of this. We're talking about reduction in cognitive load, right? Mean time to innocence, mean time to detection, mean time to repair. Why not lean on the generative AI capabilities, particularly of text summarization? And I'm tying this back to RAG because some of those techniques we talked about are certainly being employed behind the scenes here. Here's the Wi-Fi one. Look at all those dashboards. One button, here you go, you got 4 degraded APs. How long would it take you to find those 4 by clicking through these menus, right? Latency. Summarize the latency dashboards, degraded, highest, lowest, table. Click, click. None of this has been fast-forwarded. This is real-time results. So now with configs, we can do it right in the diff button. So this button here is going to give you, human text summarizing the diff between the configs. Really cool stuff. And then a routing summary. Like even just looking at this, I don't know, I need to understand domain-specific or network-specific things. I just summarized the dashboard there. TACAX will even show you, we'll see here the username. So this username did all these configs on this device. And now we're going to summarize F5. Widget summary. And then there's the full summary there. Search summaries, yeah. Okay. Good, I got that done in 30 minutes. So, in my opinion, I don't think RAG is dead. Keep it in your toolkit of tools. Keep it in mind when you're facing hallucinations. And keep it in mind with MCP tool calling, can you employ some RAG techniques to improve the tool selection? Anyone have any questions? No, go ahead.
You mentioned earlier your choice of So yeah, so Chroma.
What do you get out of visualizing some OEM JSON?
Well, so by visualize, I mean I can use Cabana, and Cabana will give me bar charts and pie graphs and distributions of the vectors. It just gives me a little bit more tangibility than Chroma, which does have a CLI. You can do CLI API calls against Chroma. I just feel that the Elastic ecosystem is more complete.
Sure.
But you're right, you're just looking at floating point numbers in a table, and maybe that doesn't matter to you. True enough.
So all the different techniques you mentioned which have been built on top of RAG, which one are you using for this summarization? Like RapRag or just
Graph, right?
RapRag?
No, we are using RAG because it's more of a prompt engineering than plus RAG.
Right.
And we don't, because the data only has the content.
Right. Okay. So it's just more traditional RAG.
Yeah.
Good, good. Yeah, and traditional RAG will get you very far. Any of the other speakers have any comments about RAG or their experiences? Anybody?
There's a great feedback loop that you're thinking about here of when to retain a tool and when to replace a tool. And like, that's something, we have engineers, right? We always want to play with what's new.
Right.
There should be like some thoughts and criteria on when we retain versus when we discard, especially in high velocity environments.
Yeah, that's a really good point. And it's almost unheard of for me to retain a tool a year later, right? Or 18 months later. So one thing I want to point out about MCP. So we at Selector have packet copilot.selector.ai. You can upload PCAPs and chat with them in a GUI. Okay? I have wrapped that behind an MCP now. Meaning from Gemini CLI, if I had a PCAP in my local folder, I could say, what's the source and destination IP in this PCAP? Enter. That's it. No code, no nothing. And it calls the Selector MCP. And what's the Selector MCP doing? It's doing that 6-step process. I've just abstracted those 6 steps as tools that the MCP has now. So now you can use the GUI, or you can use Claude, Cursor, VS Code, whatever, to chat with packets. So let's take a